Can you hear me, guys?
Yes, teacher.
Okay. So, when you think about network, you have different there are a lot of different attributes, but one of important for us now is the bandwidth. What is the bandwidth? The bandwidth is the capacity at a medium can carry data. For example, if you use Wi-Fi, you have one capacity. If you use the fiber, you have another capacity. Okay. Things in the network like a pipe. Okay. And the bandwidth define the how many data you can pass through the cable. Another important attribute related to the bandwidth is the latency. The latency is amount of time, including delays for data travel from place to other. Okay. For example, here you have a client and a server. You send a data to the client and receive the reply of this data. The latency is the time that you expend to go and to back. Okay. If you open the terminal in Windows or in Linux, give me a second. Okay, you can use the command ping. Okay, the ping command, for example, tech.mx. Okay, when I type this command, I send a package to the tech server. Okay, I go to Brazil, to the Mexico, and receive the answer. Okay, and receive the answer. And here is the time, for example, to go to my PC to the tech PC, I spend 124 microseconds. Okay, it's one package 124, 124, 125, 146. Okay, for example, if I ping another server, for example, I ping www.microsoft.com. Okay. If I type Microsoft.com, I go to Microsoft server and back. Okay. It's 7 microsecond, 8, 22, and 8. Okay. It's clear that this server is here in Brazil. Okay. The name of this time here is the latency, okay? When I type this command, it's like I did here. I send a ping, go to the server, return, and you consult 10 microseconds to go, 2 microseconds to back, 20 microseconds. It is the latency. Any question about the latency?
No.
Another attribute is the jitter. The jitter is the variation of the latency. Okay. Remember this picture here. Okay. You broke the package and the package can go to multiple paths. In part of this path, you can have a congestion, for example, a lot of package, and you increase the time to process the package. For example, back here to this picture, here, each router that you have in the path, get the package, open the package, identify what is the target of this package, and send to the package. Send to the target. Okay. If you have security, you open the package, analyze the package if you see if it has virus or other problems, and identify what is the target and send to the target. Okay. What happens is, for example, in one of these router, for any reason, you increase the number of information that you need to process. Okay? If it happens, this router don't work so fast than the past, and they require more time to process the message that we receive. Okay? If it happens, okay, if it happens, you increase the time, you change the latency. For example, when you watch the video from the, for example, the Amazon Prime or the YouTube or Netflix, for example, sometimes the image frozen, and after one time it continue the video, okay? Or the message when you talk on the cell phone, sometimes the voice starts to metalize, or the message is a little fail. For example, you start to talk and some message is you lost package. Okay. The name of this effect is the jitter. For example, here in this example here, if you see the node A send eight packets to B, okay. And what happened? The first is go, and in here you start to increase the delay because you have overloading the network, okay? And the speed that the packet 2, packet 3, packet 4 arrive to the destination, changing the time. Did you understand what is jitter?
Yes, teacher.
It's a very important concept, for example, to multimedia application, for example, video and voice, okay? In the video and voice application, we use additional technology, additional protocols to avoid that the jitter change in the time, okay? You can have the latency or the delay, but you avoid that delay change during the transmission. Okay, you keep. It's much better to keep a little biggest delay than to change the delay all the time. Okay. Okay, it's an example of the jitter. Okay, you change the speed of the arrived message. So another important concept is the network topology. Okay, network topology is not about the physical implementation of your network, but it's related to the logical implementation of your network. Okay, so for example, sometimes you don't have your computer is connect direct one to, for example, in your home, your smartphone talks with your TV, okay? It's a bit that is sent directly a message to your TV, but no, you send the message to the router and the router send the message to your TV, okay? It's the physical implementation is different than the topology implementation. Okay, the topology is about the logical layout. Okay, and this logical layout affects the network performance, the network size, and network collision detection. I will explain it later. Okay, the first topology and the oldest one is the bus topology. Think the bus topology that you have one cable and you connect all the nodes in this cable. Okay. One example of the bus topology, you can see things that you are in the one dark room and you cannot see nothing. Okay. But everybody inside this dark room has the same, share the same media. For example, think you are in a dark room, you cannot see nobody, and you want to talk with another guy in another place in the same dark room. You need to start to talk. But if two guys talk at the same time, what happened? You lost the message that you sent. Okay? For example, olá, José, como vai? If you another guy talking the same time, what happened? You listen something, but you lost part of information, or it's more difficult to understand what is the people told. It's what happened in the bus topology. Think about this example here. If you have A and B, okay, and you use the same cable, okay, everybody listen. For example, when you A send the message to B, C listen, G listen, okay, and if A and B talk in the same time, you generate a collision and nobody listen what you told. Okay, the advantage is easy to set up. Okay, the disadvantage is low. Okay, it's easy to crash. It's like the dark room. If two guys talk in the same time, you lost the information. You crash the information. Okay, what you need to do? If you two guys talk in the dark room at the same time, you lost the information, and the guy needs to talk again. Okay, you need to talk again. Any questions? And the star topology is close to what you have in your home. Okay. In star topology, you have a central point that receives all the messages, that everybody is connected. Okay. It's not exact it, for example, when you use a wireless router in your home, but it's close to it. Okay. You have a wireless router. This router has connection with the internet, and all the nodes connect to use this router to connect the internet. Okay, for example, if node A wants to talk with node B, he talks using the router. Okay. The advantage is to set up because you only need to configure this guy, but disadvantage is if this guy is crashed, you lost you lost the network. Okay. Any questions? Another type of network is the ring topology. The ring is a little different. You have a ring where everybody's connected. You have a token, okay? And you only can talk, you can talk only if you have the token. If you don't have the token, you cannot talk, okay? And what it means, for example, one wants to talk, one get the token and talk, okay? When the token is with one, nobody talk, okay? Okay, one stop to talk, okay? One release the token, okay? And the next one that wants to talk, get the token and use the token, okay? The good thing, the time to send data is no, and there is no data collision because nobody talks in the same time. The problem is slow, okay? It's not a real true because you are an example of the ring topology, like the fiber ring, that is a very fast network. It's not slow, okay? But it's more related to the past. Any question about the ring topology? No questions? Okay, the mesh topology. The mesh topology is very common today, but it's not so common, for example, to use in the local area network, but it's common, for example, to use in the wide area network. Not exactly the complete mesh, but partial mesh. What means mesh. Mesh means that all nodes is connected with all nodes. For example, node 1 is connected to this node, to this node, to this node, to this node, to this node. This one is connected to this node, this node, this node, this node, and this node. Okay? All nodes is connected with all nodes. What is the good thing? The good thing that you can ensure that the data is always being delivered. Okay? If you lost, for example, this link, you can use another path to acquire the destination. Okay? It's the good thing. The problem is very hard to set up because you need to set up all the mesh connections. Any question asked? I'm talking about very difficult things, or it makes sense to you?
Yeah, it's logical.
Okay.
Teacher, I have a question.
Okay, go ahead.
For the case of boss topology, in which case it is like the most convenient option because it has so many disadvantages. So where is the application there?
How can I say? This topology is more related to it's logical, okay? You can implement an application, you can implement, for example, a network. For example, a mesh. A cloud try to implement a type of mesh because a cloud, again, the mesh topology is not so common. A full mesh topology is not so common because it's very expensive. A partial, yes. But I give you an example. For example, a star topology. When you talk about the topology, you talk about network, not about the applications. It's about how your network is designed. Okay, you talk, for example, about, you can say, oh, my home use a star topology. Well, why? Because I have an access point. Or my, I don't know. And this example is not so common, but for example, the network that connects all the builds in the city using a fiber ring, okay, is again, when you talk about the topology, you talk more about network, not about application. Can I answer your question? No.
No, my question was about the boss topology, the first one, like when it is convenient to use it. The boss topology. Yes.
Can you rephrase your question? I didn't understand your question. Sorry.
The first case we saw of boss topology, that is like linear. I think it is previous to that one. The first slide.
The first slide.
Yeah.
Which one?
Of boss topology.
This one.
The next one. That one. When it is convenient to use it.
Yes, thank you. No, it's not good to use it anymore. Again, in the first, the first local area network that I use in my life using the boss topology. Okay, this type of topology has a lot of problems because you need to use the physical implementation of this topology is not so easy. Has a lot of problems because in the physical implementation, you need to have a cabling, okay, and you use terminators here. It's close to it, okay. It's very similar than this picture, okay. And the problem is this terminator. If you have problems in this terminator, you lost. For example, if you have problem here, all the network go down, okay. It's the reason that today you don't use anymore. Okay, I don't remember any case today that you use the bus topology. It's different, for example, than the star. The star, no. You have a star is the common technology that you use today. For example, when you use a switch in a data center, we use a star topology. When you use access point in a wireless, you use a star topology. Okay. It's a good topology to use, for example, in a local area network. A ring topology today, you use most of the time in metropolitan area networks, okay? In a specific metropolitan area network, in the metropolitan area network that you need to have a very high-speed links, okay? You can use fiber with the ring, and it works very well, okay? The mesh topology, you can use, for example, in IoT, for example. In IoT, you try to build a mesh topology a lot of time, okay? And you can use, for example, to organize the wide area network, okay? But again, not a full mesh topology, a partial mesh topology. Did I answer your question now, Leon?
Yes, thank you.
Okay, perfect. Sorry. In the first time, I didn't understand it well your question. Ernesto, did you have a question? Do you have a question?
No, and you have already answered it. Thank you.
Okay. So, okay. As I told, one important thing that you need to have is an IP address. Oh, sorry, it's an address. Okay. And today it's an IP address. All the devices has an IP address. Okay. And IP address is a unique address that identifies a device on the internet. For example, when you use a RFC or when you use the passport number is an ID that identifies you in the mesh, for example. No, there is no, it's not in, you cannot have two guys that has the same passport number. Okay, the passport number identify you in Mexico or identify me in Brazil. Okay, it's not possible to have two guys that has that have the same passport number. It's like the IP address. Only one the IP address identify only one device. Okay. There is the situation of the net. Yes, there is special situations, but we didn't discuss here in this course. We'll discuss it in the network course. Any questions about IP address? Another thing that is important in network is the network medium. Okay, a medium is links and nodes. Okay, for example, a fiber, twisted pair cabling, a wireless. Okay, it's an example of media. Okay, and the media is the aims to link nodes. Okay, and the type of media defines the speed, the level of security that you have, and the size of the network. For example, you can have a twisted pair cable. If you use a twisted pair cabling, you can connect device. One device can be connected with other device in the range of 100 meters. Okay. If you use a switch, you can go. One device can be send data to another in a 200 meters. Okay. It's the twist pair defines the level of errors, define the how many devices you can have in a segment. Okay. and the speed. For example, use a wire-based medium, for example, a 2-spec cable. You can acquire, for example, gigabit Ethernet transactions. Another one is the coaxial cabling. Coaxial cabling today is used, for example, in the cable TV. Okay, the coaxial cabling is not so good to transport package. It's very useful in the past to create the oh my gosh, what's the name? A bus topology network, okay? But today you use only to connect a cable TV. It's very protected to interference, okay? You have a very thin isolator, but don't transmit a lot of information. For example, around 10 megabits per second. And you have the fiber optical cable, okay? In the fiber optical cabling, in the two first one, okay, you transform the information in a pulse of electricity to send data. In this one, you transform the information and the pulse of light. The good thing here, it's complete this type of technology is complete, don't have any interference, don't suffer with interference, okay? Any type of interference, it's complete protected, okay? And you can transport a lot of data. For example, here you can, in the local network, you can send until 10 gigabits per second. The problem of this technology is expensive, okay? And it's very difficult to manipulate because if the fiber is very, 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 very thin, and if you don't take care, you can broken is the fiber, okay? And it's the reason that you use most of the time to connect backbones or to connect servers, not to connect the end user terminals or end user computers. The next one, the last one is the wireless, okay? The wire cable, the Cooper cabling transform information in the electric pulse. The fiber optic transform information and in the pulse of light. And the wireless medium transform information in the radio waves pulse, okay? Or microwaves. If you use local area network, you use radio waves. If you use some types of technology that you use in one, use microwaves, but to other you can use radio waves, okay? The wireless media is easy to set up because you only need to set in the device the SSID of the access point that you want, and it's all, okay? You don't need to pass cabling. It's very easy to configure, but it's very difficult to secure because things that you are, it's a shared media, okay? Everybody can listen what you talk. The consequence is if everybody can listen what you talk, everybody can send information being authenticated or not. Finally, you have the collision domain. Again, it's a property that is related to shared media. It not happens in the ring, for example, but it happens in any stars and the wires. Things, for example, PC1, PC2 try to send the information to PC3 because in this case it's a bus topology. You have a collision here and you lost you have a collision here and you lost the information. Okay. For example, another example, you have one, and in this case here, you share this video, okay? When you have collision, what you need to do, each device that you try to talk, start a timer, a random timer, and wait a time to send the data again. Any question, guys? No questions?
No, teacher.
Okay. After this break, I will talk about the wireless sense network. It's a little more deep, okay? I give a break and we return in 00, okay, guys? See you soon.